All right, this is section 5.6, part 3. We're looking at graphing rational functions. So number one, what we're going to do is we're going to try to find the x and y intercepts. We're going to try to find the horizontal asymptotes and vertical asymptotes, if we have any. We're going to take note of the multiplicities and figure out the local behavior. We're also going to see if we have any removable discontinuities as well, and take all that information, put it together, and sketch our graph. So let's look at this right here. We're going to sketch the asymptotes and graph of x plus 2 times x minus 3 all over x plus 1 squared, x minus 2. So let's go ahead and find the y-intercepts. That means x is equal to 0. So that means that's going to be f of 0 is equal to 0 plus 2, 0 minus 3, 0 plus 1 squared, and 0 minus 2. So that's 2 times negative 3 over 1 squared times negative 2. So that's negative. Actually, let's go ahead and we can cancel out some things. The two negatives here, the 2's here. So that would be 3 over 1 squared is 1. So that's 3. Okay, so I'm going to write over here that we have a y-intercept, and that is going to be 0, 3. And then let's find the x-intercept. So y is equal to 0. So 0 is equal to x plus 2x minus 3 over x plus 1 squared x minus 2. Remember, we don't care about the bottom. So the top is going to be x plus 2 equal to 0, x minus 3 equal to 0. So x equals negative 2, x equals positive 3. So that means the x-intercepts are negative 2, 0, and 3, 0. And then let's find the horizontal asymptotes. We'll go ahead and find the vertical asymptote. Okay, vertical asymptote, let's see, can I cancel anything out? Doesn't look like it. So I'm going to set the bottom not equal to 0. And then separate them out. Okay, so square both sides. So x plus 1 equals 0. So x equals negative 1. X equals 2. Okay, so our vertical asymptotes are x is equal to negative 1 and x is equal to 2. Okay, now we can go back and find our horizontal asymptotes. And note, since we couldn't cancel anything out, we don't have any holes. So we'll make a mention of that. So no holes in our graph. Okay, now the horizontal asymptote. Now let's get the degree of the numerator. So x times x. So it'll be x squared. So that's 2. Degree of the denominator. Hey, I have a 2 right here. So that means that this x will be x times itself. So it'll be x squared times x. So that'll be x cubed. So this will be 3. So the degree of the numerator is less than the degree of the denominator. And back here, we had this information. Okay, so if the degree of the numerator is less than, that's this right here, then we're going to have a horizontal asymptote at y equals 0. Okay, so we'll write that over here, horizontal asymptote at y equals 0. Now let's just plot what we know. So I'm going to go out 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so I have a y-intercept at 0, 3. So right here. two x-intercepts, one at -2 and another one at 3. And then I have a vertical asymptote at -1, so here, and at 2, so here. And I also have one at y = 0, which is the x-axis, so we'll do right here, do that right there. Okay, so now we need to try to plot this. So first off, I'm going to start with this area right in here. Now that is a y-intercept, and notice now my function can either go like this, can go up and get closer and closer to that asymptote, kind of like this. That's the first option. Or say it could go down like this. Now, a reason that I know it cannot do that is because we would have another x-intercept right here. So I know it doesn't go that direction. So say it could go like this. We know it can't do that because we would have another x-intercept right there. So it doesn't seem like it's going downward. It seems like it's going to be going upward. Okay, so say something like this. So it's getting closer and closer to that, comes down here, turns, and then hey, comes back up. Okay, now at this point right here, -1, I need to look at the multiplicity at -1, or sorry, that's 2. -2. I need to look at the multiplicity for -2, and that came from right here. Remember x-intercepts, we just set the numerator equal to 0. Okay, so this has a multiplicity of 1. Remember, odd multiplicities, they're going to cross through the graph. So our function will be crossing through at that point right there. Okay. And we know that the function will be getting closer and closer to this asymptote. And then it will, looks like it'll turn, and it's got to get closer and closer to this asymptote as well. Okay, for 3, so that's this right here. It also has a multiplicity of 1, so it'll be crossing through. Okay, so looks like it will do this number right here. Now, it could be asked, well, how do I know that it's not doing this right here? Going through this point and doing this right here. How could I tell which one is which? And actually, let me use a different color there. That'll get confusing. How do I tell that which one is which? And the only way to really tell is you would need to plot another point just to make sure. Now, say, what is this right here? That is, what, 2? So that's y equals 2. Looks like that should be, what is that? X is equal to -2. If we plug that in, so -2 for x, so f of, actually, -2. So -2 plus 2, that's going to give me 0. Yeah, I can't use that one. Let's use y equals, let's see, let's use x is equal to -4. Let's use that one. Okay, so -4 minus 3, -4 plus 1 squared, -4 minus 2. So that's -2, -7. This is -3 squared, and that will be -6. Okay, so I have +14, and I have a 9. times a negative 6. Okay, so 14 over 56. Okay, so it looks like y should be a negative value at x equals negative 4. So here is x equals negative 4. Notice y should be a negative value, so your function should be somewhere down here. If it was supposed to be if it was supposed to be above here, then y would have been a positive function. Okay, so that's how I would check to see which way that one should work. Now this next one, we know that the multiplicity is 1 for 3, so we know it's going through. Now I know it's not doing this right here, and I don't have to plug in a number. You can, but you don't have to, because I know that there's not another horizontal asymptote. Okay, so it's not doing this right here, right? So it can go through there. But if you wanted to, the easiest thing is to just check the point. But we know it goes through. So it looks like it will do this right here, and then it will get closer and closer to this right here. Okay? And that is my very rough sketch of this function right here. Now let's look at this one, and we will go through the same thing. We're going to look for the y-intercept. So x is equal to 0. So 2 times 0 minus 3, and 0 plus 4, so negative 3 over 4. So we have a y-intercept of 0, comma, negative 3 over 4. And then for the x-intercept, so that's y is equal to 0, we're going to have 0 is equal to 2x minus 3 over x plus 4. Don't care about the bottom here. So 0 is 2x minus 3, so 3 is equal to 2x. Divide by that 2, so hey, x is equal to 3 over 2. So my x-intercept is 3 over 2, comma 0. And then let's find our vertical asymptotes, which doesn't look like we can cancel anything, so that means that we have no holes. So I'm going to set the bottom equal to 0, or not equal to 0, either one. You set it to not equal to 0 when you're looking for the domain. If you're looking just for the vertical asymptote, you can just set the bottom equal to 0. That's fine. I've been doing not equal to 0. Okay, so we have a vertical asymptote at x is equal to negative 4, and we have no holes in our graph because nothing canceled out. And then let's look at the horizontal asymptote. So I need the degree of the numerator is 1. Degree of the denominator is also 1. So the degree of the numerator is equal to the degree of the denominator. If we go back to our this right here, this slide, if they are equal to each other, then that means that's the ratio of the leading coefficients. So let's go back and see what are their coefficients. Looks like a 2 and a 1, so y is equal to 2 over 1, or y is equal to 2. So I have a horizontal asymptote of y is equal to 2. Okay, now let's take all of this and try to figure out a very rough sketch of that function. Okay, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now I have a y-intercept at 0, negative 3 over 4. So we'll say that's about right here. That's almost 1 for y. And then we have x-intercepts at, looks like that is 1.5. 3 over 2 is 1.5, so that's right there. We have a vertical asymptote at x equals negative 4, so right here. We have a horizontal asymptote at y equals 2, so about there. Okay, so